Hello and welcome to today's math lesson. So far we have covered sections 8-1, which was graphing. So solving a system by graphing. 8-2, we were solving systems by using the method called substitution. And then in 8-3, we began a new process called elimination. And what we're going to talk about today is systems, okay? So we've been doing systems, but we always want to know why we use these, where we use these. Are we ever going to use this in the real world? So systems are a great way of showing you where math is used in the real world. And so when that comes up, then we talk about word problems, okay? And we're going to talk about graphing, substitution, and elimination. So today is basically going to be a review of the three concepts that we've been covering. So in this first problem, we're just going to solve this system by graphing. So this first equation I'm going to do in blue. And that first equation is already in slope-intercept form. So if this one's already in slope-intercept form, then we can go ahead and graph this. So what is the y-intercept? The y-intercept here is a -3, so we go down 3 and put a dot. Now what is the slope? The slope here is the coefficient of the number in front of x. So what number is in front of x? And here it's a 1. And we always write it 1 over 1. So since these are both positive, we're going to go up and to the right. Up and to the right. So now, because this is the first line, do you notice how I extend it going over the whole graph because I don't like to have to come back and redo things if I don't make it long enough. All right, the second one I'm going to do in red. All right, ooh, this one is not in slope-intercept form. So I want to be able to solve for the variable y. I would like to get y by itself. So in order to get y by itself here, I'm going to first subtract x from both sides. So 2y equals minus x plus 6. All right, also we have to get y by itself, so I'm going to divide everything by 2. So y equals -1/2 x, and 6 divided by 2 is 3. All right, now this is in slope-intercept form. So now I can read off my slope is, or my y-intercept is a +3, and then my slope is -1 over 2. So I'm going to go down 1, right 2. Down 1, right 2. And I'm going toward the blue line, so I'm going to keep going. Down 1, right 2. Oh, and there we go. That red line crossed that blue line. And if we want to solve the system, there's going to be one solution as an ordered pair. So this is over 1, 2, 3, 4. So the x value going in the direction of the x-axis is 4 and up 1. Okay, well, another thing we could have done solving this, I know the directions don't say to do it this way. However, we do have two equations here right now. We have this equation right here. And after we solved and got this one all by itself, we have this equation right here. So now we could do substitution, and you can set up x minus 3 equals -1/2 x plus 3. So if I add 1/2 x to both sides, this is going to be 1.5 x, and I'm going to add 3, so I get 6. And now what is 6 divided by 1.5? And that comes out to be 4. Okay, so you can see x is 4, x is 4. All right, moving on. All right, Keisha and her friends visit the concession stand at volleyball games. The concession stand charges $2 for hot dogs, so I'm going to have x be hot dogs, and I'm going to have y be drinks. All right, the friends buy a total of 8 items for $11. So they buy some hot dogs, whoops, that's supposed to be a y, some drinks, and that is a total of 8 items. Now, it was $2 for a hot dog and $1 for a drink, and they spent a total of $11. Okay, so there's a couple different ways we can do this. Now, if we look at this, do you see how it has a 1y and a 1y? So what I can do is multiply this equation by -1 so that I end up with minus x minus y equals -8. And I'm going to leave the other one the same. So 2x plus y equals 11. And now I can add these up. So this is using my elimination method. When I add these up, I get x, the y's cancel out, and 3. So I get a 3 here for x. So let's go back here to this first equation. And when this first equation says x plus y equals 8, if I plug a 3 plus y equals 8, when I subtract 3 from both sides, y is 5. So my solution here is 3, 5. What does that mean? That means that these groups of friends bought, so what they actually purchased or what they actually bought was 3 hot dogs, because that's what I said X stood for, and 5 drinks. And that's how they got their total to be $11. Okay, now we also could take these equations and we could solve and get y by itself. So let's take this first one. X plus y equals 8. Subtract x. So y equals minus x plus 8. 1, 2, 3, 4, 5, 6, 7, 8. And then I have a negative slope. So I'm going down 1 over 1, down 1 over 1, and I get this red line right here. All right, now I'm going to do the blue one. So the blue one would be 2x plus y equals 11. So when I subtract 2x from both sides, subtract 2x, I get y equals minus 2x plus 11. Oop, I'm going to go off my chart here. So that's 8, 9, 10, 11 would be up here. And I'm going to go down 2, right 1, 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 down 2. Okay, so the blue line comes like this. So there is the point where they have in common. So in over, let's just take a different color here, green. So this goes here and here. So that's 1, 2, 3, 1, 2, 3, 4, 5. So we get the ordered pair 3, 5. So you can see you can solve this system by doing graphing, by doing elimination, and I could actually show you one more method and show you what substitution would be. So substitution would set this equal to this. So I'd have minus x plus 8 equals negative 2x plus 11. And if I add 2x to both sides, I have x plus 8 equals 11. And when you subtract 8 from both sides, we get x equals 3. So we have x equals 3 substitution, x equals 3 by graphing, x equals 3 by elimination. Okay, 3 different methods, all getting to the same solution. All right, Bowl-O-Rama. Write a system of equations with one equation describing the cost and the other describing the cost to bowl at pins. For each equation, let x represent games. So x is going to be games. And y is going to be total cost. Okay, so if we go to Bowl-O-Rama, okay, the total cost y is going to be shoe rental fee is $2, and it's $2.50 per game plus the $2 for the bowling fee, bowling shoes. All right, pins, their total cost, they said they wanted y to represent the total cost, is going to be They only charge $2 per game, but they charge $4 for the shoes. Okay, so they want us to graph this, but when we graph this, we have a $2.50 here. Could I just use substitution? I've got y equals. So can't I just use substitution and say $2.50 x plus 2 has to equal 2x plus 4? They want to know when these two things are going to be equal. So let's subtract 2x from both sides, which gives us 50.50 cents x plus 2 equals 4. Subtract 2 from both sides, so 0.5x equals 2. So now we're going to divide both sides by 0.5, so x is, and what happens when we take 2 and divide by 0.5? 2 divided by 0.5, we get 4. Okay, so 4. Let's go back here. I'm going to plug the 4 in here. So we have 2 times 4 plus 4. So we have 8 plus 4 is 12. So this solution here is 4, 12. Okay, 4 stands for games played. And this is the total cost. So when are these two bowling alleys going to be the same? They're going to be the same when 4 games are played. And the cost of playing 4 games is $12. Okay, so $12 is your total cost for playing, or bowling, I should say, 4 different games. Okay, so now sometimes businesses want to know when a different one is going to be cheaper. So if you're only going to bowl 3 games, so let's say you're only going to bowl 2 games, okay, 2 games. If you are only going to bowl 2 games, which place do you go to? Are you going to go to Bowl-O-Rama or are you going to go to Pins? Well, you put the 2 in here and you find out. So put a 2 in here. 2 times 2 is 4. 4 plus 4 is 8. So it'd be $8 at Pins. Put a 2 in here. 2 times 2, 50. So that'd be 5 plus 2 is 7. So if you're only going to bowl 2 games, Bowl-O-Rama is your place. If you're going to bowl 4 games, either one. More than 4, then Pins will be better. All right, last problem here. The Bensons and Hagans went to a Twins game. After the 5th inning, treats were purchased. The Hagans bought 3 hot dogs and 2 hamburgers, spending $19. So let's let hot dogs be X and hamburgers be Y. So the Hagans bought 3 hot dogs and 2 hamburgers, and they spent a total of $19. The Bensons bought 6 hot dogs and 2 hamburgers, and they spent $28. How much did 1 hot dog cost? Okay, so how much is a hot dog? Well, let's add this up and see what happens. So I am going to leave this one the same. So I'm going to leave it 3x plus 2y equals 19. And then I'm going to multiply this by -1. So -6x, -2y, and -28. All right, let's add these up. So we get -3x equals -9. Divide both sides by -3, so x is 3. So what does that mean? Hot dogs cost $3 a piece. So let's put this 3 in here. I'm going to use a different color. Let's put a 3 in here. 3 times 3 is 9 plus 2y equals 19. Subtract 9, so we're going to get 2y equals 10. Divide by 2, and y is 5. So that means, what was the other one? Hamburgers. So burgers are $5 a piece. All right, it is now homework time. So good luck on these word problems.